Okay, welcome to the Propeller 2 live forum today. TeamOz presents MicroPython for the P2. We have Tubular and OzPropDev ready with us down under. Good morning, guys. Before I turn over to you, and I'll introduce you again, what's going on at Parallax? So these boards are still in production. We're having issues with our test fixture, which we seem to have resolved, but it added a week. And the big problem with this kind of thing is it's delayed other things we sell lots of. So expect us to be out of stock of a lot of products pretty soon. And trying to get everybody to back to work full time. That's another story. So end of next week, we hope to ship these. I realize several of you have combined it with this. So we're just gonna wait and then try to get everything together. By the way, the cable's included. Don't forget to switch power and ground on your wiring. Okay, I don't know the consequences of that, but we do have ready to go like 50 of these, another 180 coming. So I have secured a decent medium-term source for them, thanks to a Raspberry Pi project that's gone awry somewhere in Shenzhen, China. And Rich tells me that his board is now available again through his Etsy shop, in his mom's Etsy shop, excuse me. So go buy them, and there's a fix to this board that fits all of our adapter boards without conflict. Where's this thing? So these are also a delayed build at Parallax. If you've got these on back order, like a few dozen of you do, we're looking at mid-August right now. Not parts issues, parts availability issues, just getting it on our pick and place line. It's going to take some time. And as I mentioned before, we're making an adapter for the clickboards from Micro, and that PCB is ordered. I should have these in stock no later than late August because there's really not much to it. And then we'll be able to leverage everything through the evaluation board that they make. I mentioned this before. If you have any applications using the Propeller 1 or really the 2, I really want to know about them. We're building a new website, and it reflects very heavily on our commercial interests as well as education. So we'll be featuring products made by others, and this was something our customers really loved, and somehow they disappeared from our website when I wasn't paying attention, but I'm bringing all this back. Also, with us today, I think, is Riley and Jeff and Mateo will be working on an ESP32 object, and they've had a lot of talk so far. Pretty soon they're going to bring it to the forums, and we'll be partially funding this project with them to get it done. We hope to have one very good, useful object, and I'll expect to see that on the forums too pretty soon with them talking about it, so we can all give feedback to them about what we want. So we want to get it done once and get it done right. So be on the lookout for that. Sound good?
Mm-hmm.
Awesome. Yeah, and welcome to the P2 live forum. Also this week on our GitHub, thank you, Johnny Mac, for 2 new objects. You got anything to say about these? You're muted.
Being I work in show business, these things are always very important. For the really hardcore programmers, you'll notice they're very simple bits of code. Neither one of them use smart pins, although one, in fact, is a UART, and I haven't really figured out how to best use a smart pin. For those of you that have never done DMX, there's a big break period ahead of the byte stream. And right now, I'm just not sure how to deal with that cleanly because the P2 is so efficient. Writing a UART technically takes about 4 lines of code. And it's almost less code to set up the smart pin than just to do it in a loop. Same thing with the Sony IR protocol. I'm doing delta timing measurements. I'm not using smart pins to measure the periods yet because I haven't really figured out a clean way to do that. But both objects work really well. And later, if somebody can point me in the right direction for measuring bit periods for the SICRS or a clean way to transition on the DMX, great. Otherwise, they do work and they're nice and easy.
Thanks, John. And this guy, he's, I don't know if he's here today, but he's following up with some improvements to his debug tool. He's got some additional ideas he called me the other morning about at 6 a.m., but he can share those when he's ready. And today, we have TeamOz presents MicroPython with the P2. Welcome, Tubular and OzPropDev.
Thanks, Ken.
Thanks,
Turn it over to you guys.
Good to, thanks everyone for joining us as well.
Yeah.
Good to see some familiar faces. So, yeah, look, today we're going to be talking about native P2 MicroPython, which is something 3 or 4 of us here in Melbourne, Australia have been working on over the past 18 months or so. It's a little bit different, but mostly similar to Eric's MicroPython, which is built into the Flex GUI environment. It's a nice, but both systems are actually quite capable now of extending beyond just a MicroPython environment and loading extras in through additional cogs and cores. So yeah, we hope to do some demo. We'll actually have a Propeller 2 driving the video, which is going out to the conference a little bit later on. A little bit about TeamOz in inverted commas. Most of it is this guy here, Brian, who's OzPropDev on the forums. He's been spending a lot of time with MicroPython. Roger, who probably isn't awake yet, I don't see him online, so he's he's keeping late hours at the moment working on hyperround drivers for the P2. He did the MicroPython compilation for us. And he will also do the next compilation around version 1.13 when it comes out, whenever that is. It might not be too far away from what Damien George says. MicroPython is creation by Damien George, who basically started off as a bit of a dare from a friend to implement Python for microcontrollers. And it implements a lot of the features of the latest Python language as far as, is practical. It's a pretty good and useful implementation. It doesn't have everything in there, and obviously memory management, is limited due to the microcontroller, but it's pretty useful. It's also seemingly on the march. It's growing in popularity. The latest Lego Mindstorms EV4 has actually got a MicroPython engine inside it, and the Mindstorms, the Lego Mindstorm series is interesting because actually in version 1, like EV1, they actually used Forth as a language or as an engine inside the controller. In version 2, they used a Lua-based system. And in version 3, they had like a full sort of Linux stack. And then in version 4, which is just sort of filtering into the market now, they're actually using MicroPython under the hood. So it's a bit of a vote for the growth of MicroPython. The other thing that's happening with MicroPython is it was one of the projects which has been selected for Google's Season of Docs. So in the coming months, there'll be a documentation effort with some added interns doing some documentation on MicroPython. And hopefully we're hoping that, sort of P2 can kind of mirror whatever images, whatever efforts are done on the documentation at the same time. All right, so can we get possibly a show of hands for those who already got some familiarity with MicroPython? Okay.
And you could always use the reaction button, and there's a little thumbs up down there, and they could see that thumbs up.
Yeah. So that's a very brief introduction to MicroPython, but it's certainly a nice language. Brian and myself are both, I guess from early Microsoft languages in programming in the late 80s and early 90s, and we find it a joy to use and to program in. It's certainly sort of won us over in a way that maybe C hasn't in recent times. So yeah, I hope everyone gets a chance to play with it on the P2 and see if we can do good things for you. We certainly you can be using it in products without a question. It's something we're looking to build P2 products with MicroPython enabled to allow customization of the product and for gluing to other systems, basically. So we're going to just go through 3 demonstrations today. The first one is going to be using MicroPython from a serial terminal environment. And then the second demo will be using it from the new editor by Nick Tollevi. That's a cross-platform tool which enables some additional, there's like a couple of little bolt-ons which are inside that product which make it sort of useful for education. I know, I think Ken's already been using it in some of his educator programs, and with the Cyberbot via the microbit, BBC microbit. So it's sort of relying on the BBC microbit support. One big advantage which the P2 brings is just a heap of memory space compared to that kind of constrained space that the microbit operates in. Hello, did we just lose it there for a moment?
Looks like we're all back.
Okay, good. Right. Yeah, so BBC microbit. So the P2 obviously brings, 8 cores, which can be doing things. You can have the main MicroPython cog in one core, and you can have 7 other, PASM-based supporting cogs all running together to create a pretty neat application. And that also goes some way to alleviating speed issues. If your MicroPython isn't fast enough, well, PASM2, you're not going to get a lot faster. So, so the demonstration today will actually be having, the one MicroPython cog augmented by multiple other cores doing things like your USB keyboard and your video driving, and also code editing, which we'll get to. All right, so we might start, if we can cut across now to the first demo. We're also going to switch to video. Instead of being on the webcam, we're going to actually cut across to the development computer. So you won't see us from now on for a while, but we'll come back and we'll ask questions at the end of the first demo. Okay.
Yeah. So you've got a PST.
All right, can we see the PST window okay?
Looks good.
Okay. The font's big enough? It's clear enough?
Yeah, I'd say it's perfect.
Okay.
Yeah, it's great.
Okay. So the MicroPython in its basic form, you connect to a serial terminal, 115K, and those of you familiar with Python, it's interactive language, so we've got the standard prompt there, and you can just type in your commands from the PST, and it'll just execute from there. You can define your smaller objects or whatever. But once you get to a certain point with PST or your basic serial terminals, when you want to start writing bigger code, you need to shift to a different way of thinking. The MicroPython has a method of loading programs in. So if you have a terminal program that you can actually output text files down the port, you can edit your files elsewhere, whether it be in New or Visual Studio Code or even your basic text editors. And then it has a paste mode that you can put the terminal into that mode, paste your code in, and then it'll process it at the MicroPython end, and then you can run the code. So from this point here, I'll just bring up the help screen there. That just shows what the basic terminal modes are from within MicroPython. But being an interactive language, I'll just do some basic stuff here. I can type strings, for example. I can print multiple strings, and you can just type in variables, and you can start processing things straight away. So that's the basic setup that we've got there. All MicroPython versions pretty much work the same way. It's through a serial port, and you can just start using it straight away. So whatever device you've got hooked up to that serial port, that's your way in and out of it. I'll switch over now to the Mu editor.
Yeah, it might be.
Yep.
What do you want to show or ask questions about? You know,
oh yeah. Well, is there any questions at that point? That's a good point. So there was a no.
Have we lost audio?
Anyone out there?
Yep, you're there. So everybody has been muted, so I'll let them know. If you want to ask a question, just unmute yourself, and then you can ask it too. And probably also their various mute buttons disappear on them. So
right,
you can hold your space bar down to temporarily unmute.
That's a good tip.
Yeah.
One thing, I don't know if you can show it at this stage, Brian, is the tab completion.
Oh yes.
One of the features of MicroPython is the ability to complete lines with using the tab key.
I've just imported a module there, GC, which is the garbage collection module. So if I type GC and period, and I hit the tab key. No, do that again.
It's a PST thing.
I think PST grabs the tab key for other purposes.
Of course, yeah. Yeah.
I think we've not got the right PST version, to be honest, because I think we changed this already.
Yeah. Yeah.
Yeah, you're right. So maybe have you got another serial terminal?
I'll do that in. I'll show that in Mu. But I mean, one of the things that's nice about MicroPython is that the help facility that it has for the different objects allows you to see what's available in the modules that you have set up.
Wrong bracket, right? Sorry. Yeah.
So there's an example there that in the garbage collection module, it's showing you the different functions that are available in there. So even when you generate all your own classes in MicroPython, the same thing applies. So it's very easy for any of these modules that you build. MicroPython sort of attaches onto it and builds these sort of little help screens. And also things like your string handling and things like that, which are all built into it as well. You can access all that through these help screens. Yeah, but I'll show the tab completion in an editor that actually supports the tab key. So do we switch over to Mu there now?
Yeah, I think let's if there are no questions about the driving it from a serial terminal, we might cut across to Mu, which is a little bit more feature packed.
Yeah.
Okay.
Actually fast today.
That's cool.
Okay, so can you see the Mu screen there at all?
we do. And we also see one kind of open spaced bar that's like a zoom on top of the Mu. I'm not sure where that comes from.
That's at my end, because I don't see too good. I've actually got an accessibility aid that's running on the top of the screen.
Sounds good.
So yeah, so do not adjust your TVs. That's at my end. Yeah, so we're in the Mu editor there at the moment. It just has some basic buttons at the top for loading files from your hard drive. And normally with some of the MicroPython boards, they have inbuilt flash that flashes the program across. At this stage, we haven't quite got that set up at the moment. I'm actually working on a file system at the moment that will be able to accommodate that. I can show you half of that working.
And
in a
Brian,
minute.
should it be noted you're using the alpha version of a Mu?
Oh, yeah.
Okay, I'll paste a link to that
Yeah.
directly in the chat. And
Yeah, that's a good
when
point.
people go there, it's shown in the pink. Try the alpha version of Mu.
Yeah. Yeah, the later versions have more hardware-specific settings on them, and this version is more open-ended, I suppose. And we're using what they call the raw mode for downloads, which I'll show that now. So basically, we have an editor here now that's quite nice. It has some good zoom features in it. It's also got syntax highlighting in it, and it also has a function button that you can actually check your code. That's sort of a pre-parser to the MicroPython. So any of your little standard little syntax errors that you make, Mu's got a nice little utility for picking those up and giving you warnings about things it's not quite happy with. Some of the things that it does point out is to do with things like line lengths or spaces after comments. But from my experience with it so far, MicroPython doesn't seem to be worried about it as much as what Mu is. So but it might be that possibly earlier versions of MicroPython it was a problem, but this current version, which is 1.11, is the one we're running at the moment, is fairly recent, so it seems okay. So from this point,
Okay, they seem to have gone muted. I'll unmute them. Repeat the last 30 seconds of that.
oh, okay. So what I basically did then is at the top of the screen, there's a REPL button, which you could almost say is a terminal button. When I clicked on that, it split the screen and it brought up a terminal on the bottom of the screen there, and you can see the MicroPython output on the bottom there. So the code that I have sitting on the top is just some demo Python code. There's about 800 lines of code there. So one of the other buttons that's at the top here, now when I have to be in this REPL mode for this to work, if I hit run, it goes into a raw download mode, and it actually has downloaded that code down into MicroPython. So we now have that code sitting there ready to go, and MicroPython's waiting for us to make it do something. So what I'll do is I'll just do a directory command. I don't know if you can see that okay. There's a whole bunch of label names that have come up, which is module names and some of the definitions that I've got to do with some of the video driver stuff, and I've got some servo demos and buttons and things like that. So this just verifies to me that I know that that code is actually loaded in and has run okay. So I'll run a demo now. I've got, this is all running on a P2 evaluation board. I don't know whether I've got an image or not. But I've got...
hang on, sorry, you want the... So,
I'll just bring up a picture for you guys.
you've got the output of the... Is that what you wanted? The VGA output?
I was going to say, have we got an image of the board setup?
Yeah, I've got a GoPro here. I can...
Okay, just bring that up.
This up. All right.
You guys can see that okay?
You have a number of GoPros.
Yeah.
So maybe you need to select the one on the board, maybe the one in the upper left hand. Looks like a high security operation. That works.
There you go.
All right, so
Okay, so you can see the board there, okay?
Beautiful.
Okay, so we've got a USB connector on the top. We've got the video connector. We've got the control board with some LEDs and buttons on it. And I've just got a couple of RC servos hooked up here. And further around, I've just got a prototype board set up, which I've got a CNC style manual pulse generator. And I've also got a parallax joystick that's on the other end of this cable here somewhere. There it is. So I'll run a code that just interfaces to the joystick and just runs the servos. Just bear with me for a sec. Okay, so what you should be seeing on the screen at the moment, oh, I don't go actually.
I'll cut to the screen.
Let's cut back. Yeah. Okay, we're back at the Muse screen.
You're at the VGA screen, actually. You're at the Muse
We'll
screen.
go to the Muse screen. Okay. You can see that okay?
Yep.
Yep. So the Muse terminal, you'll see it's outputting some figures on there, which is just the servo values. If I move the joystick around, you should see those values changing. Are you seeing that okay?
Yes.
Yes.
Okay, now those values are being output in what they call tuple format. Now, one of the advantages of Mu is it has a plotter function. So if I just pop up to the top of the screen here, and I click on plotter, and you should be able to see in the bottom right-hand corner, there's a rolling plot going on. And then as I move the joystick around, you should be able to see the analog values appearing there. I'll just do some fast movement. You can see that okay?
That's great.
So that's one of the nice little features of the Mu editor is this plotter that's built in. And I'll just stop that for a moment. And basically, you don't have to do any sort of fancy trickery to interface to the plotter. Mu is actually snooping and watching the terminal output, and whenever it sees data that's in the tuple format, which is just surrounded by the round brackets, it'll just grab that data and it'll just plot it. So you can have a number of points. I've got 2 values here. If I had 8 values, for example, we would have 8 traces. The only thing you have to be aware of is that the serial interface in Mu is not super fast and it doesn't have a big buffer. So if you try sending a lot of channels at high speed, you'll get a buffer overrun and it complains and carries on. But for a lot of basic stuff, where you just want to have a look at the output of a temperature sensor or even in this case, joysticks or any other sort of analog values, you just wrap it in parentheses and just output it to the terminal, and you will just listen into that and it automatically scales the plotting and it'll just print it out. So that's not a bad little neat feature to just check on what's going on with any of your sensors or any of your data. And like I say, there's no special drivers or anything you have to do or any special interface. All you have to do is just output it in that format and you will just pick up on that and run with it. So a nice little feature. But that sort of stuff, the P2 would be perfect for that, listening in to the output of MicroPython. And for something like Roger Lowe's VGA driver or video drivers, you could do a similar thing where you could actually plot graphics using a P2 rather than using Mu. So it's not a bad way of doing it. In fact, I think Chip was talking about a similar thing with the debugger last week. So that's Mu in its basic form. It's a nice little editor, and we can use that and we can just load files down into the board and run them. and we've got the addition of that plot function. Now the plan is, down the track, once I've fixed a few bugs, is that this should be able to send the code down and actually flash it into the board so that you can reboot the board and it'll just run whatever the last code is that you've put in there. So for something like your robot projects or the like, that's just the missing step at the moment, is that to be able to lock this into the SPI flash and just run it. So there's a file system that I'm working on at the moment that attaches into all this. That allows you to store stuff locally on MicroPython and have it auto boot and run in whatever project that you want. So the next step from there, which is sort of what the motivation was, or part of the motivation with this MicroPython in the first place, was the idea of self-hosting. So we might switch over to the...
Yeah, well, we might, if we just pause there for a moment and just ask
any
questions, because there's a bit, although it's just some servos moving, which are all done with other boards, there's a little bit going on there. Obviously, there's multiple cogs talking to each other. There's smart pins which are generating the servo pulses and reading the analog values. So has anyone got questions regarding that setup or what it's doing? Everyone feel like they've got a handle on what's going on?
There is a question in the chat window here. When you import, is that a file on the card or in memory already?
That's a file that's actually sitting on the PC end. It's not actually it's not local on the board itself.
It's being sent through from Mu.
Yeah. So Mu is downloading it serially down into MicroPython.
So can you explain that again? So you added a code module from MicroPython?
No, what I've done is the code that you see on the top of the Mu screen, which is about 800 lines of code there, that code there, when I hit the run button, that is sent down through the serial line, down into MicroPython and loads in. MicroPython has two different ways of receiving programs through the serial port. One is called the post mode, which is just simply a text mode that if you've got something like a Teraterm terminal or anything that exports a text file, it'll just send down. MicroPython just listens in and it just accepts it all and just loads it up and then processes it. The other mode is what they call a raw mode, which is pretty much the same thing, except it doesn't sort of really echo back through the terminal. And this Mu editor actually uses the raw mode. So the program that you see on the top of the screen, which is all text, when I hit the run button, that simply just gets sent down the serial line, down to MicroPython, and it just absorbs it and processes it. I can go into that a little bit further in the next demonstration because I've got some sort of debug tools and things that are in MicroPython that can actually show that side of thing actually happening from the other end.
I think the question was, when in your source code, when you do an import of a Python module, where does it get those from? Does it pull
right. Okay. Some of those are actually built into MicroPython itself. I think earlier I brought in the GC, which was the garbage collection module. That's actually built in to the image of MicroPython. There's a few that are built in there that are to do with the board layout, the interfaces to the whatever board it is that you're running. So some of your I/O control, and whenever you type import and it brings in some of those modules, they are actually part of MicroPython, and they're actually sitting there sort of dormant, I suppose, and they're only brought in. The reason why a lot of those things are sitting there dormant and they are only activated when you bring them in is with MicroPython, when you type in any sort of function names or whatever, it goes off and it searches for matching names. And the more of that stuff that you have loaded in that you're not using, it just slows down the whole process, and it affects your program speed. But in larger versions of Python, a lot of that stuff, when you do import, it's actually bringing it in off your hard drive and brings it in. But we haven't quite got that luxury with MicroPython, obviously, because it's a stripped down version of its big brother. But it's but the plan is, with the file system that I'm working on at the moment, is that you will be able to bring in files that are stored locally on the SPI flash.
From the Mu editor.
And from MicroPython itself.
That's great.
From a terminal. So that's the ultimate plan. Is
wonderful. And the interpreter you loaded previously with Peanut or with Propeller tool?
Yes. Yeah.
Okay.
So yeah. So yeah. Any other questions there? Okay. So I'll switch over to the P2 output on the VGA. Okay, you guys can see that?
Wonderful.
Okay. So basically what we're seeing here is the same as what you're seeing on the REPL screen in Mu, except this is from the P2 itself. What's actually happening is, and this is the beauty of the smart pins, is the normal serial traffic that we have going in and out on pins 63 and 62. I've configured pins 0, 1 and 2. They're all smart pins. 2 of them are asynchronous receivers and one's a transmitter. And I've got one of them is actually listening in to the traffic that's coming in on pin 63, and it then grabs that data, retransmits it on another pin, and I've actually reconfigured pin 63 not to listen to its own pin, but to listen to one of these other smart pins. So basically what I'm doing is I'm redirecting the traffic from 63 into another smart pin, grabbing it, and then I'm sending it back out. So as far as MicroPython is concerned, it doesn't know any difference. It just sees the data. But because I've got that data, I can then grab that and output it to a video driver. So anything that's output from the MicroPython itself will actually get output onto the VGA screen. But the beauty of that too is that it then allows me to inject data into the stream as well. So not only data coming from a serial terminal in, but from internally within my stuff, I can send commands to MicroPython. So it's a way of tapping in, redirecting the output, and also allows me to inject data back in as well. And the same thing is pretty much happening with the data that's coming out from MicroPython. I'm listening in on the pin 62, and that's being fed in back into my stuff as well. So that's what's nice about the redirection facility and the smart pins, is that you can tap into that, and as MicroPython isn't aware that there's anything that's got in the way. So yeah, so we've now got a VGA screen there. And there's also, this is because I've got a USB keyboard plugged in as well. I'm now not running from the Mu terminal at all. I'm now running from the USB keyboard. So we're basically, I don't even need to have a PC connected at this point. I'm actually running from the P2 itself. So if I just move across to the different keyboard, now anything that the missing link here now is, okay, great, I've got a keyboard and I can type commands and I've got a screen. But what was missing then was a means of being able to edit code. So the idea there of the self-hosted is that I've got an editor, so I'll just flick across to that. So I'm still in the MicroPython, but it's now got its own editor built into it. I don't know if you guys can see that okay? So,
Yes.
okay, so basically it's just your normal sort of editor. I'm just scrolling down here now. This is just a whole bunch of code. You can see I've got some basic coloring highlighting in there of the syntax. And this has all the standard sort of, you can highlight code and you can delete and you can do all that sort of stuff. So this is all built into the into the P2 side. So you don't need the PC. So you can edit code from here, and I can actually send this out to MicroPython and say, okay, well, we'll load that code up and run it. So that's actually taken that code that I had in the editor, and it's actually sent it out to MicroPython, and we have that code just sitting there. So for example, I've got a video test just to sort of show the sort of things that you can do.
While you get that ready, Brian, if you can handle a question. So
Yeah.
there's not an editor. The editor is actually MicroPython with a VGA, right?
Yeah.
Okay, and that was a question someone asked. What's the overhead of the editor? What text size can it manage? Did that get answered right, Jim?
Okay, so the editor itself, it's not actually written in MicroPython. It's actually written in PASM, and it's sitting in one of the cogs. And most of it is cog and LUTexec, but there's a little bit of it that's hub. But it's independent. It's running in a separate cog. So I'll just bring it back up again so you can see it.
What kind of text size could it manage?
That's 30 by 80 characters is the screen size, and at the moment I think it allows 128K of file size.
Brian's code that he's working with there is around 1,000 lines, I believe.
Yeah. Yeah. Does that answer the question?
I think so. This is amazingly cool. You're liberating us from Windows. First Mu, which runs on a Mac, and now this.
Yeah. So the idea is with this is that with the file system on the SPI Flash, you don't need a PC at all. You can just do all your MicroPython editing live here from the P2 board. You don't need a PC. I'll just bring up another little screen. This is some files that I've got just sitting in the SPI Flash, and I'll just pick one of the files, and I'll just send it down to MicroPython and run it. And that's actually was just reading the SPI Flash and just dumping out. I've obviously picked an address that's got nothing in it, but so that was that sort of shows the file system. I've got the read side of the file system working. That's the right side that I broke a week or so ago, and I've only just worked out what I've done wrong. But as you can see, if I flick into the editor, because it's PASM, it's super fast. And so it's not a full-blooded like Visual Studio Code type editor, but there's enough in there that you can
show them tabs, do the tab.
Yeah, you can do all your normal sort of editing and stuff. And one of the things that was nice in Mu, which I think you pointed out, Ken, was to be able to select and do your tabbing, which is nice within MicroPython.
Yeah, that is nice.
So there's a few little things that I need to add to the editor. Things like obviously find and replace, and some of the key things that are the things that we use every day. But the core infrastructure's there, pretty much ready to go. So I've just got to finish off the file system, which has got wear leveling in it as well, because it's using the SPI Flash. But at the moment, the write's not working, so technically nothing wears. at the moment. But yeah, so that's sort of where we're heading with it, to make the thing completely standalone. But if you do hook it up to a PC, it still behaves like MicroPython should, through a serial terminal. Yeah, any questions about that side of things?
I've got a
How
couple.
easy is it?
Oh, go ahead.
How easy is it to use an SD card instead of the flash?
That's planned as well. Baby steps for me. I haven't had much luck with the SD cards. I seem to be allergic to them. They don't like me for some reason, but I will get back to that onto the SD side. Then you've got the flexibility of both worlds.
Yeah, MicroPython itself has reasonably good support for SD cards, and so I suspect the plan will just be to allow or just do that SD card support through what MicroPython has built in.
Yeah.
We started off thinking, oh, we'll do everything with an SD card, but it was just a series of small issues that we had with it, which means that, you know, the SPI flash, which is on every single board, makes more sense for us going forward anyway.
Yeah.
Okay,
One
just
thing I
so-
was going sorry, was it?
Yeah, just so you're aware, I'm planning not to put flash on my boards.
Right, okay.
I'm just planning to put straight SDs.
Yep.
I don't see the need for flash. I see it as an unnecessary step now that we've got SD on it.
Yeah. Yeah.
I might be alone on that, but that's my thinking.
Sure.
Well, my view of this is, I want to say first, you guys, Parallax thanks you a whole bunch for the work you've been doing on this. I know it's massive, and I know that you've been busy the last month doing your paid job. So we thank you. And if you notice, we've been pushing MicroPython for the last year via the microbit in anticipation of this, so that we can convert some of our customers to the P2 who've been using MicroPython, especially in education, because that's a very important part of our company. So this is great to see, and this opens up the world to a larger ecosystem than we've had, which you really need. I have four quick notes if I can go over them.
Yeah.
You talked about them, yeah. So one of them was the module importability. That's you're working on that. I think that's going to be great when that exists, because you can go into that file manager and just add a module, and then we can start to bring in other people to contribute modules. And second thing was, you didn't mention the board type. Right now with the alpha version, when you've loaded the interpreter, it shows up as in one of the Espressif boards or the ESP board. So that's good, because you're mimicking it for when people try this. And the third thing is, it's like an architectural question, and not being much of a programmer, I just want you to comment on it, which is MicroPython interpreters running in one cog, and you've got all this other spin2 assembly stuff running in other cogs. And so the thinking that you have in mind about how spin2 could operate in other cogs from MicroPython's interpreters is how?
At the moment, with Spin2, I need to dive into that a bit deeper, because they're two sort of completely different animals, and it's about them getting on with each other in terms of the hub use. But at the moment, most of the stuff that I've got going in here is all PASM stuff. As most of you know, that's pretty much what I live, eat and breathe. But it would be nice to be able to do some of this stuff in Spin, because MicroPython is reasonably large, and plus we have, it requires 128K of heat. There's a bit of mucking around and in sharing all the resources without anything sort of stepping over the top of each other. But yeah, the plan is to be able to come up with a way of hooking in some of these modules that other people are writing and patch them in, and you can just bring them in off the spy card, a spy flash or the SD card. But at the moment, I haven't got Spin2 stuff working with it.
But you do have this PASM, so that's amazing. Does that mean that you would be able to, when you have the file manager working, you'd be able to take something you've written in PASM and then add a module to the interpreter?
Yeah, that's the plan.
And then leverage those resources in another cog from Python?
Yeah, that's the idea, that you should be able to bring in another file and load it into a cog and run it into another cog.
Well, I think that's downright awesome.
Yeah.
Well, do you have an assembler? I see what looks like assembler code there.
No, this is just Python code that you're looking at there.
Yeah, but it seems to be building assembler constants. So do you have a way to assemble PASM code in Python?
No, there's no way of doing that at this stage. But down the track, I suppose we could do something like that.
Did you implement?
It might be disassembling PASM.
Okay. Question then, do you have a way, like, did you implement the cog init that I had in my interpreter?
No.
So yes.
Sorry,
yes.
Sorry,
the
yes.
CPU method.
Yes,
Eric,
sorry,
yes.
yeah.
Your CPU, sorry.
It's the thing in the forum which.
Yeah.
Yeah, so you can load PASM code into another cog if it's compiled already.
Yeah, that's right. Yeah.
Okay, well then in principle, I mean, we could create some way to convert spin objects into Python, sort of like spin to CPP does.
Oh, yes. Yeah, that'd be neat. Yeah, for sure.
I just want to pick up on, Ken, you mentioned how we're using the ESP mode at the moment. The forum user, Roscoe PC, he maybe a year ago or so had a quick demo of the P2 mode, which he had compiled into the new editor. And we've corresponded a little bit recently, so he's getting back onto that work, and so we should ultimately end up with a generic P2 mode. But both the ESP mode and the P2 mode is probably planned at the moment a very transparent mode, so that's why we can use it fairly easily as it is, and also why adding a P2 mode shouldn't be too taxing.
Great. So at that point, you'd have a board type that appears for the P2 on the mu when you connect to mu, and that would eventually get wrapped into their distribution.
Right.
Yeah.
We need to work out a logo.
Sorry, guys, I'm just a tiny bit slow. I just did a couple of objects over the weekend that are primarily in PASM with a bit of spin interface, the Sony infrared decoder and the DMX transmitter. What do I need to do to take that spin interface and convert that to MicroPython so that the PASM can run and I can do those same things in the MicroPython environment?
At the moment, that's a little bit tricky. The interface between MicroPython and PASM doesn't really exist because MicroPython never really had that sort of facility in the first place. It was never really designed to run on a multi-core machine. So the original sort of design of MicroPython, we're sort of trying to steer it in a direction that's more suited to P2. So a lot of this stuff that's running here now is, you can almost say it's a facade that's sitting on the top of MicroPython to put it on steroids, I suppose, to add and tap into some of this P2 stuff that we've got. So yeah, the ease of attaching in PASM code at this stage, it's not as easy as what you can do it in Spin2. But the plan is to make that easier, whether it be through file systems or the like, so that we can tap in and make the most out of P2. at the moment, I'm using a lot of the cogs at the moment because I've got quite a bit of diagnostic stuff that in a part of the development. So I haven't got a lot of, I think, in fact, I think I've only got one free cog at the moment. Actually, just as a side note, just because of that, I'll just bring up a different screen. If you guys can see that okay? So
Yep.
what that screen is this is actually a live view of the P2's hub memory. So the bottom of the screen is the whole 512K, and the top part of the screen is just a snippet of hub that we can actually look at what the actual contents are. So what I'll do is I'll go back to the Mu editor, and I'll just download some code, and you can actually watch what goes on when I actually download. So earlier when I had the Mu screen, you saw that I had some code on the top and I had a REPL screen on the bottom.
Yeah, can we just maybe explain the screen? So the red area of the screen is the hub memory, where each sector is, I think, 128 bytes or 512.
512.
So each red P in the red section is 512 bytes, and then it gets zoomed and broken up into the top section, which is in the dark blue, and so that is the contents of those bytes. So every one of those sectors is sort of expanded, and you can just choose one of the sectors to break out. Yeah, but I think just sort of trying to explain the screen layout a little bit.
Yeah.
On the right hand side there, the green is just the interpretation in ASCII of the blue data. So you've got every single byte of one sector on display at a time. Yeah, sorry.
Yeah. So if I'll hit the run button on Mu, which is going to download through the serial the 800 lines of code and then process it. And what you should see is a lot of flashing going on, and it'll show where there's actually activity happening in the hub. So I'll just start that now. So you can see the code being downloaded into it and then it being processed. Did you catch that at all?
Yep.
I'll do that again. Just code being downloaded and then MicroPython processing it. So there's a bit of persistence there, so you can actually see what's going on. So this allowed me to work out what MicroPython was doing and what a lot of my stuff was doing, and whether I was clobbering MicroPython or vice versa. And I did have some weird stuff happen at one point and I couldn't quite work out what was going on. And using this technique, I was able to actually see where there was activity and thinking, well, why is data being written there? That's got nothing to do with me or the like.
Do you want to explain the U and the B down the bottom? Yeah,
the U down the bottom, that's actually the USB keyboard driver sitting in hub. And then the V is actually the video buffer, and you'll see flickering going on to that because it's actually seeing itself and there's a flashing cursor. It sees that as being a change in hub. So that's why you've got activity there. And the small H's that you see, that's some of my hub exec code and where it's actually sitting. And the rest is sort of free memory. So I can, I've got the facility that I can actually move around within the memory, and I can actually examine. You can see a cursor moving around, and I can actually pick areas of hub and actually watch the data live. I'll pick a spot again, and we'll see if we pick up on any data. And you can see the blue screen at the top. There was a bit of activity then. So yeah, basically this is just a window into the P2's hub where I can watch everything all at once. And it's amazing what you pick up on, and it's interesting as well just to see what goes on behind the scenes. So that was just a development tool I just needed to find an elusive bug, and it ended up it's been quite useful.
I may have missed it in your explanation, but are all the areas that are marked by P, is that available for user program in MicroPython, or?
That's MicroPython and the 128K heap combined. And that's also quite a few of the inbuilt modules as well. So that the heap, if I run that again, you'll probably see the 128K area of heap is where the most activity is. So that's part of the MicroPython image. So there's not a huge amount of hub memory left for user applications, but I'm just looking at the screen there now. There's probably about 16K in the top of hub there, and there's probably what's that, about another 10K there. So yeah, you could attach in some smaller PASM code in there. But some of the ideas we've got there too is to also strip out some of the things that there may be stuff that people don't want for their application. So we might have a few versions of it that, you know, for example, if you didn't want floating point or some of these other functions, that they could actually be stripped out. So there may actually be different variants depending on what you're doing. It seems to be also we have quite an active MicroPython community here, and which we're lucky enough that Damien George, who's the actual creator of MicroPython, is part of. But it seems to be there's a challenge of the local guys that who can make the smallest version of MicroPython that still runs and that does actually something useful. I forget what the record is at the moment, but there was one fellow who had a small controller, and I forget what model it is, microcontroller he was using, but it wasn't very big, and he just wanted to basically read a sensor, I think, and control a relay and a few things, and that was about it, a couple of LEDs. And so he made a real stripped down version. But yeah, for P2, it's quite possible that we could have a number of different versions, and it depends on what flavor you want as to which version that you load up. But yeah, that's any questions on that screen you can see at the moment?
There's been
Very
a lot of
interesting.
discussion going on the chat about how to integrate spin and PASM, which I'll save and get off to you so you can look at it.
Yeah, okay.
Very interesting debugger. I'm always interested in how different people debug their code. I put an article on how I debug my code.
Yeah.
That's a really good way of snooping the hub.
Yeah.
So
yeah,
I take it that's in its own cog.
Yes, that's in like a diagnostic service cog that I've got. So yeah, it's just reading the hub memory, and it's just reading it in blocks, and it's storing all the results in LUT and in cog as well, and it's just running as fast as it can, and I just have a bit of persistence on it. But yeah, it's been very useful actually to you know, silly mistakes that you make where you put a wrong address in or something, and you can see the data going somewhere where it's not supposed to. But being able to actually look at you see some crazy things going on, and you can actually go in and have a look and see what sort of type of data it is, and then it gives you a clue as to where it's come from. So yeah, it's been quite useful. I mean, my favourite debug tool is an LED. Just blink an LED when you arrive somewhere or when you get out. This one is another useful way of doing it. I have actually got a debugger that uses the hardware, the chip built into the chip, and it's an interactive debugger that is actually written in Spin 2, but unfortunately, because of space and complexity, I wasn't able to use that with this setup. But that might be another thread coming up on that, hopefully, when I can find a bit more time to finish it off. But that's an interactive debugger that you can single step your code, and it supports multiple cogs. And but yeah, that's a whole new ball game as well.
With MicroPython, do you see, you were talking about being able to cut it down to quite a small code base for the main piece. Do you see it might be feasible to have more than one version of MicroPython loaded and running at a time? In other words, MicroPython in one cog and MicroPython in a second cog?
That would be tricky. That would be nice to be able to do that. I did talk to Damien about multi-threads running with MicroPython a while back. He had some ideas on how to go about it. They possibly would need their own heap. It would be nice.
Yeah, I was thinking specifically not multi-threading, but a separate version where you might have just some simple code running.
Oh, yeah. Well, that's a possibility.
We probably need to look at what, because MicroPython's also got a Linux port, like for node board, a non-hardware kind of port, and it maybe supports multiple cores and has some ability or threading. I'm not sure. We started off thinking, oh yeah, we should build this in from the start, but it's proved to be both not as easy as we originally thought, and also not as necessary as we originally thought. So it's a nice idea, but of course, if you just halve your hub memory, I think MicroPython, the main part of it takes about 200K roughly, and then we reserve, there's a heap space above that and some working memory and things, but you would not get a whole lot of working memory on each of those. If you sort of bisect the hub memory, you're going to have a fairly limited environment size for working in. And I think one of the big things we can do with the P2 is, use that 512K, spread out a bit, and plus you've got all the smart pins doing their thing, and you've got 7 other cores as well. So we're probably not in a hurry to get multiple MicroPython instances working at the same time.
I very much like the editor that you've got in there, because that opens up a whole pile of things, being able to edit on the P2 itself. Yeah,
that was the thing that sort of drove me towards it was the missing link, I suppose, with the self-hosted, that we can generate video easy enough, and thanks to the great work that Gary J did with the USB keyboard driver, it was those two bits, it was like building blocks. That side of the things was easy. So it was, the missing link was just a means of editing the code, and obviously the final link is being able to save and load that. Once that's all tied together, you're away. Yeah.
Right. What else have we got? Any other questions on? I think this is pretty much what we wanted to cover today. So, what other questions have people got? Have people got any applications in mind that this might be useful? Or I should probably mention a little bit about the plan. If no one's got questions, the plan moving forward is we're waiting for MicroPython 1.13 to come out, which will have the little FS support. It's already got, 1.12 has already got little FS support, so 1.13 will also have that. We'll release the code, like when Roger does that compilation, he'll write up some notes and release the code for that, so people can change portions of it if they want to. Yeah, we've got a number of examples which we've used internally, which we also plan to release. Actually, Brian, you know what you haven't shown is the actual the BS2 functions.
Oh yes.
And compatibility. So one of the things we were looking for earlier was just some kind of language which we could use to exercise smart pins in a simple way. We ended up sort of starting down the path and maybe making our own commands and things, and then we realised we're really just duplicating the work of the BS2 language. And so we actually implemented a whole lot of sort of BS2 compatible commands, which makes it easy to, to do things like, I don't know, PWM pins or etc. So
Yeah.
and this is built into this image.
Oh, what's going on?
Yeah. So
I think it'll really be nice when you have the ability to make all the code classes objects. What do we call them in MicroPython that you've written here be able to be tucked into a module?
yeah. So at the
And-
moment, I've just got classes that are written up, but yeah, to be able to actually build that into MicroPython at a later date, that's the plan. There's a few more ideas we've got on some of the basic I/O functions that are, because the P2 is such a different animal to the micros that MicroPython was originally developed for. We need to add in some stuff that Damien never ever thought you would ever need, but because we've got P2, we need to add them in.
It's
So
a tremendous
it's sort of-
benefit. You've got him down the street.
Yeah, yes. Even though he's busier than what we are, but yeah, he's quite good at, and he's very intrigued with the P2. Some of the stuff that we've been able to do with it, even the debug, the live memory stuff. He said he wished he had something like that when he was actually developing MicroPython, but we came too late. So, yeah, so I'll just do a quick example of some of the stuff that are built in with these BS2 style type functions. I'll just define a pin, and I'll use the set up like NCO frequency. So I'll just call the pin X, for example, and the function that I've called it NCO frequency. I'll just type that in. What pin that I want the frequency on, and I'll just say that the frequency is 5 Hertz. Now, if I had a camera pointing at the board, you would actually see that there's an LED that's blinking here at 5 Hertz. What I've also built into some of these BS2 functions is for people who are trying to learn about smart pins as well. I have a facility that actually shows what I actually did in the background with the smart pin. If you can see that pop up on the screen there. Yep. So what that actually is that shows what my class did in MicroPython behind the scenes. So if you want to learn about smart pins and what was actually done, what you see on the screen there, you could actually cut and paste that into a PASM program and it'll do exactly the same thing as what I just did. So a lot of these functions, things like driving the servos, which would be a PWM sawtooth mode, or measuring a pulse in or whatever, some of these functions that I've got built in also will show you what the equivalent you would have to do in PASM to do the same thing. So anyone who's trying to learn or make the jump from this early MicroPython stuff into how smart pins work, this is a bit of a link just to help out there.
Have you also got an analog input capability?
Yes, there's an analog input one there, which is what I'm using in the joystick program.
If you want to go to new, find it in new.
I'll see if I can find it in new. And
Some of these smart pin capabilities are so far beyond the P1, like the analog and the pulse generation and the frequency stuff you're demonstrating. It looks like multi-core with a single core, right?
yeah, well, that's right. And that's the beauty of the smart pins, is that a lot of this stuff is just set and forget. Things like the servo modes and things, that you can just give it a value And because the smart pin maintains and looks after that, you're not adding any sort of overhead to MicroPython. It can go on and do its own thing, and it adds incredible power to MicroPython, where on some of the other macros that run MicroPython, they have to stop and go off and maintain and then come back, and your main program loop actually starts slowing down, and you start getting into timing issues, and it starts becoming a bit of a headache. But like we keep sort of saying, with a P2 and with the luxury of having cogs and smart pins, we can do so much more with this MicroPython without actually affecting your main loop speed. It's a nice luxury to have.
So from a feature standpoint, we'll have the most capable MicroPython, but with initially the smallest amount of modules available.
Yeah, initially, yes, that's right.
I think that's a good place to be.
Yeah. Yeah, well, even with some of this stuff that we've shown to some of the other MicroPython guys, they can't quite get their head around, that we're generating video and interfacing to USB keyboards, and we have encoders and all sorts of stuff going on, and yet we can still be in the REPL and be typing commands, and servos, pulse trains are just running continuously, and some of them can't quite get their head around that all this is happening without sort of doing all this threading. So yeah, it's a good match.
In the chat, there was a mention of compressed Python libraries. I think he's talking about frozen modules. Does P2 MicroPython support that? And is there any plan to support that?
We haven't really experimented with them, but we believe, I believe it can, and if it's not, it's probably just one of those initial compilation switches when you're building the MicroPython compilation. I think it's sort of something which is, in fact, I'm not even sure, does a garbage collection use a frozen bytecode module, or is it? It's really a question for Roger, or Eric for that matter. But I believe we haven't done a lot of work with the frozen bytecode, but I believe it's sort of part of, if we want to go into that direction. I don't think we're stopped from doing that. It's just, we've got to explore a little bit further. Do you have any thoughts on that, Eric, on the frozen bytecode?
I think it's just something you can enable. I haven't played around with it very much.
Yeah.
Yeah, the advantage is it's fast and doesn't sort of get digested. You know how we were watching the P2 digest the code with the memory map before? The frozen bytecode just comes in and just runs, and so it's it's more compact. It doesn't use as much memory when it executes.
Yeah.
Can MicroPython access Hub directly?
Not yet. That's one of the more unique P2 things that need to be added in.
So Brian has a service cog where he sort of does what he needs to do outside of MicroPython, and so you could add something in there. We're reviewing all the interfaces between the different cogs. We have been using smart pin mailboxes as a messaging technique, but we're just looking, there might be smarter ways of doing it. I think Eric alluded to some other possibilities as well. So
yeah, I was thinking of specifically for mailbox access to PASM and to spin.
Yeah. Yeah, at the moment, that's one of the missing links, but because a lot of that stuff I'm doing in other cogs externally, it's not actual MicroPython that's doing it, but that does need to be added in to the list of P2 specific commands that need to be added in. It's one of those things that once we sort of got this going and started using it, then we realised, okay, we need to add this is something that we're used to and spoilt with P2, that the MicroPython hasn't allowed for that, because the micros that it was originally developed on, they don't require anything like that. But we're sort of, when you look at all the different versions of MicroPython that are available, P2 really stands out as being totally different. So yeah, we need to make MicroPython P2 versions capitalise on all this power that we've got and all this I/O.
Well, could we take some more questions from any of the participants and viewers before they start their day down under?
Yeah.
I notice we have a number of people here who've not participated before, which is good. While they queue up any questions, we won't have, unless somebody schedules, much going on during the month of August. So we do want some presentations though. If anybody would like to share anything, we have, those spots are open until September. So we have 4 or 5 dates. We have some desired presenters that I'm working on still, but it's open for everybody. If anybody wants to share a project they're working on, you can do that. Just go to the forums and add your name to that list.
Yeah.
So round up any final questions or comments?
It's certainly advancing really well. This is looking really good, guys.
Thanks, Ray.
Yeah.
Yeah, we're super excited about it at Parallax because it gives us a path forward as well. And we plan on supporting you as soon as we can too, and getting more involved in helping make this go.
Yeah.
I'm kind of almost envisioning building a little mini suitcase that I could take MicroPython with me now. It's just a display and a keyboard.
Yeah.
Now we're gonna have to bring back those old keyboards we had.
Yeah.
And a LiPo battery.
So I'm still working on the Tower of Power.
Are those P2 boards?
That are all P2 boards, A and B. I bought all the other, I kind of harvested all the old ones. And basically that's supposed to kind of do that serial ring buffer so that I can combine a couple of them together.
Wow, I think we got to send you a special free lunch because that's a lot of hardware.
You already did. You sent me 2 P2 version B. I bought all the A versions from other forum members, and I have 2 of them which are from Parallax. They are from Parallax.
Very cool.
You sent Chip said I have to get them, and somebody sent them. I don't know. And I'm working on that ring buffer. Basically, it is, but it isn't. Not yet.
Well, since you mentioned boards, in anticipation of MicroPython furthering, we are planning a BOE style board that would take a socketed P2 module in it. So at some point,
that would be very nice. Yes, yeah.
Yeah, I feel like I like the demo board for all the things you can connect to it and use, although I'm not really doing that yet. But I still feel like I want to be on a breadboard with sensors of my choice and hardware that I'm used to and things that some of our, usually we work with certain customers. That's kind of my learning environment. So we'll have both.
And the next product would be a flip module with pins on both sides.
One side, yeah, the size issue is a big consideration here, the socket thing. We have so many pins on this chip to deal with.
No, actually, honestly, after those project boards with just that serial, those my beloved, we stopped them. I hate it. The best other module is honestly your flip module. It's
Flip. Oh yeah.
very, 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 very. I mean, okay, that web server thing, that Spinneret was also nice. But the flip module is honestly a really nice product. The only thing which is missing is a jumper between reset and USB, so that you can stop it from resetting all the time when you plug in something else.
Yep.
So just jumper between reset and that would honestly, you should do that on all your boards. Just a fucking jumper between reset and USB, so that you can pull it out and then up, you know, doesn't matter. You know?
Well, Jeff and I are both here, so we'll take note of that. And I think also the MicroPython TeamOz would like to have an LED on those little boards so that they know the interpreter's running.
Yeah, Brian's favorite debug tool.
Yeah, my favorite
single
device.
LED.
We will give you that LED and we'll give it to everybody. I agree with you.
Cool.
So for those who are scrolling down the text talking about PDBs, the issue with making, I want a PDB too. They're talking about the professional development board, the big square thing with all the stuff on it. And I imagine what it would have now would be really cool. VGA, HDMI, whatever, sockets for arrays, SD cards, on and on. So those things, they suffer a margin problem when we make them. We just can't make any money. Your expectation is you want them for $200, but the design cost can be honestly $20,000 to $30,000, and then we can't get by making those for $20, you know, like you'd really want. There's just not any margin there. But if we sold enough chips, then maybe we could do that. You know. Anyway, what I'm saying is, if anybody wants to make something like that, there's certainly a niche. You know, you aren't going to see a ton of boards coming from Parallax. We're not going to make a lot of hardware this time. We want this to be open to others, but we need at least one or two things. So if somebody wants to make a PDB and present it to us, I think there's an opportunity there.
Yeah, I mean, the PDB is one of my favorite boards. I have, you know, since years I have that thing. But what I think you also should kind of support is that little small module from Peter Jakaki, the PD2B, whatever. It's small, you can connect it to, I mean, that is something which is easy to handle for, you should build something like that, even just build that one from Peter.
Well, we have a similar idea. Peter's going to be talking about that in September, by the way. He hasn't confirmed his date, but he's coming around. So if anybody else wants to make a presentation, August is open. Eric, if you want to come back with more Flex GUI, whatever, we would welcome that. Or anybody else.
Yeah, let me think about it.
Okay, great. So we'll conclude Propeller 2 live forum for the day. Want to thank TeamOz. This is super exciting. Looking forward to the next version of MicroPython being ported to the P2 and then having the file available so we can all try it.
Yep.
Sounds good.
Yep.
TeamOz is doing a great job. It includes many more people than these two guys, but it's the highest per capita P2 developer concentration of technical people anywhere in the world.
Don't forget Canada.
Oh, we'll never forget Canada.
No.
So yeah, we just have to bring some of the Europeans back into the mix here. They're a little quiet. There's only a handful of them. And those that are active live here like you.
I
really hope that I can get that Ringbuffer thing running in the next couple of weeks. Right now it's just running on the A boards and I have to kind of figure out the change to the B boards. But that thing, if it's running, it would be worth the presentation. But I can't promise anything right now.
No problem. We'll be ready. And maybe Johnny Mac will share some of his implementing some of his code, how to use it at some point too. He knows we're very interested. Yeah, and we're not pressing him because he's so productive at what he's doing right now. He has to make a living. Unmute yourself there, John.
Yeah, I think John is currently the most providing person in the new OBEC into thing. God, there's stuff coming in. I love it, and he is honestly, he should make a course about how to write good readable code. He is good at that.
Well, I don't want to give away too much, but Ken and I have been working on a project for a very long time that addresses that.
Sometimes it takes a lifetime, doesn't it?
Well, you know, it's tricky being an artist and an engineer because both sides are like this, and you know, at some point I'll say, okay, enough is enough, John, just release the material. But one of, you know, for me personally, I mean, I'm excited about all of these things, you know, with the Propeller 2. I have an affinity for spin and I like it, but, you know, thanks to the work that Eric has done, I do little bits of C now and then just to experiment. And when I was working for the cybersecurity company, all of my coding was in Python. So I have a joy with that now too. And being able to do that on the Propeller is kind of neat. It'll be fun to see as both sides of these things mature, being able to do what I just instinctively do now, what we all do, be able to take, you know, to write Spin 2 and, you know, knock some assembly together and make it all work nicely. To have that work effectively in any language, I think it really sets the Propeller 2 in particular, but the Propeller family up to get the rest of the world to say, wow, why haven't we been paying attention to this stuff? Because I don't know how the rest of the group feels, but when I go to little tech conferences, the last one was the Hackaday Super Conference of, you know, last fall. And I had people come up to me and say, hey, you're the Propeller guy, right? And I said, well, yeah, I'm one of them. And they would ask questions about the P2 and we're very excited. And what ultimately happens, I find, especially when I'm dealing with prop guys in the movie business, they are misinformed about the Propeller. When I set them straight, they get very excited and say, wow, I didn't know that. And so I think there's an opportunity for all of us who do know the Propeller to get that story out there and get people to think a little bit differently and to explore other opportunities that the Propeller gives them.
Well said.
Yeah, well said, John. Straight from the king of propellers. Okay, well, we'll end on that note. Again, thanks so much, TeamOz. We'll be talking soon. Everybody have a wonderful morning, evening, day.
Yeah.
Thanks, guys. Everybody take care.
Thanks, guys.